Okay, so let's look at the problem. So the simply supported beam has a section of W40 by 46 of A992. It supports a reinforced concrete floor slab that provides continuous lateral support of the compression force. The service 6.6 kilonewton per meter. This load is superimposed on the beam. It does not include the weight of the beam itself. So the service live load is 8 kilonewton per meter. So the question is, does this beam have adequate moment strength? So according to the problem, the beam is provides a continuous lateral support. I-highlight natin. So ano daw siya? It supports a reinforced concrete floor slab that provides continuous lateral support. So kung babalikan na yung inisip na erase siya. So kung babalikan natin NCP, na meron siyang continuous lateral support. So kung babalikan natin so from NSCP 2015 requirement, meron tayong tinatawag na lateral torsional buckling. So, di ba, sabi natin, if meron tayong continuous lateral support, I think I've discussed that. Pag meron tayong lateral support, ibig sabihin, walang lateral torsional buckling na mangyayari. No? So, even we don't need to if looking here dito sa side ng natin, so, diba, we have options yung lateral buckling, lateral torsional buckling. So if walang continuous lateral, so this will fall under category number 1, wherein your LB is less than or equal to LP. No? So dali na yun. Kapag meron siyang continuous lateral support sa compression flange, walang nangyayaring LTB or lateral torsion buckling. Therefore, we can say that your LP is less than LP. No? So we will make use of the first condition. No, so kung yung LB is less than LP, kasi nga no lateral torsional buckling will happen. No? So regardless of the length, no, kapag meron siyang continuous lateral support, i-assume natin na magpo-fall siya under category number 1, wherein there's no lateral buckling present. So in that case, it's LB is less than LP or your MN or your so ito siya condition 1 from NSCP. So it's or MN is equal to your MP. Yun yung nandun sa earlier. So ito yun So the limit state of bakit nagalaw? Nag-overlap kasi. So is it not here too? Sorry. See. So yun. So, pwede natin sabihin na your MN is equal to your MP. No? Wherein your MP is equal to, di ba? This is equal to Fy times Jx. Okay, so to solve for this, check muna pala natin if the section is compact or non-compact before we apply the kung kasi 'di ba, first step is checking if your section is compact or non-compact. Yun muna pala yung una natin gagawin, sorry. So first is check for shape classification. So to check, no, check natin yung flange. So for the flange, we have, uh, sorry, balikan ulit natin yung NCT. Dito tayo sa table. Ayan. So, this is a flange of rolled section, no, I shape. So, dito tayo sa number 10. So, for the flange, we have width to thickness ratio. Kung mapapansin nyo, yung B over T is only half of the flange. So, pwede nating sabihin na this is B over T, no, or half of the flange over T. So, para simple, lagay na lang natin B over 2T. So, flange to, lagay natin BF over 2 TF. Okay? Para mas madali. Kasi yung B is half, so yung BF divided by 2. So, ito yung magiging equation natin for the width to thickness ratio. Uh, so, reminder lang no, na this actually represents your, sorry, hindi pala. Kunin yung sinabi. So, yung BF over 2TF, let's check. So, isulat ko muna yung equation. Now, to check, no, check natin kung compact siya or hindi. So, we will copy the equation. 0.38 square root of E over F1. So, yun yung pang-check natin. For the ano naman, tawag dyan, for the web, muna natin, dito yun sa kabila. Ito yung web natin, ayan. Number 15, web of doubly symmetric I-shape section. So, mayroon tayong H over TW. Mamaya ko na i-substitute. And then, ang pang-check natin kung compact siya or not is it should be less than 3.76 square root of T over Fy. So, substitute natin. Meron pa ba? So, ano siya, no? Ang pag-check kung compact or not, your B over 2TF, BF over 2TF should be less than this. No? Tapos, kung greater dyan siya dyan, magiging siyang non-compact. No? Kapag greater than dito, tapos less than dito, ano siya, non-compact. Kung yung width to thickness ratio natin is greater than also dito, saka siya magiging slender. No? So, yun yung ano natin for checking if compact siya or not. So, check muna natin. Let's see. So, nasulat ko na din naman. Sorry, wala na tuloy. Yeah. And so we have maghang calculator. Restart na. Naghali. Sige, ito na lang isa. Alright. Okay. So, solve natin. We have F over 2TF. BF is 140 over 2TF. 2 times thickness of the flange is 7. So, we have 10. Thickness of the flange, sorry. Thickness of the flange is 11.2. 11.2. And this is 140 over 2, 70 divided by 6.25. So, sulit natin. Now, for the, we have 0.38 times square root of, sorry, E is 200,000 all over Fy, which is, I think Fy is 345. I forgot to write it here lang. So, 9.15. So, as you can see, BF over 2TF is less than 0.38 P over Fy, or lambda is less than your lambda P. So, section 8 at compact. Check muna natin yung H over TW pala. So, we have, ang H natin is just the height of the web itself. So, bale, we have 403 minus 2 times the thickness of the branch, 11.2. So, ito yung height. 380.6 divided by the thickness of the web, 7. So, we have 54.37. Yan naman. 3.76 square root of 200,000 all over FY 345. So, 90.63. So, similar, no? So, we have the lambda is less than your lambda P for your web. So, therefore, the section is compact. So, therefore, section is compact. So, since compact siya, we will refer to this, ano yun? Punta na lang. Punta tayo dun sa summary. Ito. So, kapag compact siya, no, we will make use of this. No? So, yan. So, if the shape is compact, check for the lateral torsional backlink. As I have mentioned, according to the problem, there's a reinforced slab, no? So, this is, there's no lateral torsional buckling that will happen. So, it will be LB over, LB is less than LP, wherein your MN is equal to your MP. So, ito lang yung, gagamitin natin. So, madali lang, no? Since ito lang naman, hindi tayo mag-involve nitong napakahahabang equation. So, di ba, we know that, to get your JX, we need to compute for your A. Since this is symmetrical, madali lang natin makompute yung area. So, same process of what we did earlier to compute for your Z. No? So, we will get the plastic neutral axis. So, since this is symmetrical, it's just Dividing this into 2 will provide us with a neutral axis for the plastic moment. Then again, di ba, since will your bar Y, symmetrical naman siya, so walang problema doon. So we have A is equal to 2 bar Y. So to compute for your bar Y, again, I will just have to write area 1, di ba, Y1, plus area 2, Y2, all over area 1 plus area 2. Wherein your area 1 is equal to, so lagyan natin na lang ng marking. This is your area 1, no? This is your area 2. So area 1 is 140 times 11.2 equal to 140. Oh, sorry. Mali. So, bale, area 2 naman, sorry, Y1 muna pala. Y1 now equal to, then the distance of the centroid, with respect to the plastic neutral axis, so this is your Y1, so that is just equal to 403 divided by 2, so 403 divided by 2 minus 11.2 divided by 2. So 195.9. Okay. 195.9. Okay. Area 2 naman is equal to, so highlight tuloy natin. So this is area 1, and this is area 2. Na. So palitan natin ang color. So, area 2. Ano area 2? So for area 2, we have, what is ilang height niya? 403 divided by 2 minus 11 point. Point times 11 multiplied 7. So we have 90.3 times 7, 1332.1. As for the Y2, and we have this height centroid of area 2 with respect to, so Y2. Y2 now is equal to 190.3 over 2. 190.3 divided by 2. 195.50. So bar Y na is equal to, substitute lang natin. 1568 times 195.9 plus 1332.1 times 25.15 all over 1568 plus 1332.5. So 149.625. 63. So I've mentioned area A is just 2 bar Y. So higher total height is your A. So your A now is equal to 1449.623 49.623 times 2, 299. Diba we have ZX equal to area total over 2 times 8. We have area total over 2 is just equal to, diba? This is just equal to area 1 plus area 2. No, kasi half na siya ng area total 2. So we have area 1 plus area 2 times A. So direct substitution, we have 1568 plus 1332.1 times 95.15. So we have 27, ay, sorry, ang A pala is bakit 95.15, sorry. A is 229.246. So bali 867.843 times 10 raised to 3 cube. Now for your MP, this is just equal to FYJX, or in your MP, is equal to, di ko na isulat na, so your F is ano ka to? So times 345 divided by 10 raised to 6. Walang 10 raised to 6. Wala. So divided by 10 raised to 6. 299. So 299.406 kilonewton. So the question is ano na, the service, the dead load and live loads are provided. So the question is, does this beam have adequate moment strength? So the capacity or the moment, the plastic moment capacity of the section is 299.406 kilonewton meter. So therefore, the loading applied should not exceed this MP. So therefore, we are going to compute the factored moment or the service moment of this beam, and then compare it to the plastic moment capacity of the section. So before that, no, we will, since ang sabi dito is service load, no, so gagamit tayo ng multipliers. So since service load to, and then ang tanong is adequate moment strength, di ba? Pag strength, we will make use of your LRFB. So making use of your LRFB. No? So yung LRFB din gagamitin kasi strength ang tinatanong, di ba? We have your P is equal to 0.90. So we will have P of your nominal, wherein your nominal now is equal to your MP. So we will just multiply 299.406 times 0.9. Nawala yung ano. divide 26. So, 269. So, ito yung ano, ito yung capacity ng section natin. So, ang gagawin natin is we are going to compute the actual loading that it will carry based on the given sa problem. So, according sa problem, meron daw tayong service dead load or the weight the dead load is equal to 6.6 kilonewton per meter. So, according to the problem, it does not include the weight of the beam itself. So, as I have mentioned before, the W403 by 46 actually indicates the depth and then the depth and the weight. So, this is the depth, di ba? So, 403. Then this here is the weight. So, 46 actually, sulat ko tuloy dito. So, we have W403 by 46, wherein your 46 is in kilogram per meter. Di ba? We know that 1 Newton is equal to kilogram times meter per second squared. So if we want to convert the 46 kilogram per meter into Newton per millimeter, we would have to multiply it with 9.81, di ba? Yung meter per second squared. This, pwede mo siyang i-multiply sa 9.81 meter per second squared. So that we will have Newton. So for the weight of the beam, lagay ko na lang weight of the beam, weight WB, okay, weight of the beam, we have 46 kilogram per meter times 9.81 meter per second squared. That will give us your Newton per meter, di ba? Kilogram meter per second squared. Ito, this is actually equal to Newton. Okay, magiging Newton siya. So, the answer here will be Newton per meter. Since we want kilonewton per meter, divide pa natin ng 1,000. So, that will be kilonewton per meter. So, therefore, that is 46 times 9.81. The answer here is in, this is Newton per meter. So, to make this kilonewton per meter, divide natin ng 1,000. So, we have 0.45 kilonewton per meter. Or 51. So, the total dead load is equal to 6.6. Oh, sorry. Ano, 46 times 9.51 divided. Ano yun? Plus 6.6. We have 7.05. So the total dead load is 7.05 kilonewton per meter. Now for the live load naman, I think provided naman siya. The live load is 8 kilonewton per meter. So for the service uniform load, di ba, multiply tayo 1.2 weight of the dead load plus 1.6 uniform load, live load. So, we will just substitute the values for yung factored uniform load natin is so 1, 2 times 7.05, 1.6 times 8. Tama ba 8? So, we have 21.26 kilonewton per meter. And then, to get the maximum loading caused by this maximum moment caused by the uniform load, di ba, we have M maximum is equal to WL squared over 8. So, substituting the value, we have W 21.26 times the length is 9 meters. So, M max or MU is equal to 21.26 times 9 squared divided by 8. So, 215.26 kilonewton per meter. So, as you can see, 215.216 kilonewton meter is less than your MP, which is 299.406. Therefore, so since less than siyang MP, we can say that, therefore, the section is adequate. So, the section is adequate. Yan. So, ulitin natin yung process. So, first thing we need to do is check if the section is compact or not. Then, after checking the shape classification, we will check if saang category ba siya, if under LTV ba siya or not. So, in this case kasi, as I have mentioned earlier, it is stated already in the problem that there is a continuous lateral support, so the lateral torsional buckling is not present. Therefore, we will make use of condition number 1. No. So, yun. I still have two more problems. So, I will continue this by next meeting because it's almost time already. So, before we end, do you still have questions or clarifications? None? Sige. So, if wala na question, we will continue next week on site.